This is our first video for 7.3 where we will be establishing some trigonometric identities. I'd like to begin with some review of the basic trig identities that we've already looked at in this course. So starting with the reciprocal identities, recall that secant of theta is the same as 1 divided by the cosine of the same angle theta. Cosecant of theta is the same as 1 over sine of theta. And cotangent is the same as 1 over tangent of theta. Then we have two quotient identities that can be used on the tangent and cotangent functions. Tangent of theta is equivalent to sine of theta divided by cosine of theta. Cotangent of theta is equivalent to cosine of theta divided by sine of theta. All right, some other identities to review. Recall the Pythagorean identities. Sine squared of theta plus cosine squared of theta. Remember that always equals 1. And then our second Pythagorean identity, 1 plus tangent squared of theta is equal to secant squared of theta. And then 1 plus cotangent squared of theta is equal to cosecant squared of theta. Lastly, we have the even and odd properties. Sine, cosecant, tangent, and cotangent, those are all odd functions. So that means when you evaluate them with a negative measure, you will get the opposite value as if you evaluated with the positive of that angle measure. So what I mean by that is that sine of the negative theta is equivalent to the negative of the sine of positive theta. Okay, and it'd be the same for the three below. Cosine and secant, those are the only even functions. And that means that evaluating cosine with a negative angle measure theta should yield the same as if you evaluated cosine with the positive of that angle. Same for secant. All right. So all of these identities can typically be used when we're trying to establish some more complex trigonometric identities, okay? So in general, when I say that we're establishing an identity, it means to prove that two sides of an equation are equal to one another through the use of basic identities like the ones we just reviewed, and then algebraic manipulations, okay? So first identity I'd like to establish is that cotangent of theta divided by cosecant of the same angle theta is equivalent to cosine of theta, okay? And typically when I establish an identity, I usually try to start with the more complicated side of the equation and use my properties and my algebraic manipulations to simplify it down to look like the other side of the equation, okay? So I'm going to start with cotangent of theta over cosecant of theta, all right? And I'm going to manipulate it so that it simplifies to cosine of theta, okay? So first thing I'll do is I'll take cotangent of theta and I'll apply a quotient identity to it. Cotangent of theta is the same as cosine of theta over sine of theta, okay? And then cosecant of theta, I will use a reciprocal identity and rewrite it as 1 over the sine of theta, okay? Now I just simplify this using some basic algebra. This is a complex fraction, so you have a fraction divided by another fraction. You could just multiply by the reciprocal of the second fraction. So this is equivalent to cosine of theta over sine of theta multiplied by sine of theta over 1. And notice these will reduce away to where you are just left with cosine of theta. And that's what we were trying to prove in the end. Once we get it to equal out to what we are proving, just put a check mark next to it to show that it's been verified, okay? Now, another approach I suppose you could have taken to this is, instead of thinking as multiplying by the reciprocal of 1 over sine, you could have taken the complex fraction and you could have multiplied it by sine of theta over sine of theta. These would have wiped away, so would have these, and you'd been left with cosine of theta as well. All right, so a couple approaches give you the same result. It's very important when you are establishing these identities that you show all of your work. Okay, write everything down. Do not skip any steps. Be very deliberate in the work that you show. Okay, next example. Cosine of theta plus, or divided by 1 plus sine of theta is equal to 1 minus sine of theta over cosine of theta. Okay. I wouldn't say either side's more complex than the other, so I'm just going to start with the left side, and notice I'm giving us a little bit of a hint here. We're going to use a conjugate on this. All right, so I'm going to take the left side, and by use a conjugate, I mean I'm going to multiply by 1 minus sine theta over itself. All right, that's the conjugate from the denominator. And here's what that's going to lead me to. Okay, I'm going to need to distribute, and then down below I'll have to do first and last parts of FOIL. So that's going to take me to cosine of theta minus sine theta cosine theta, all over 1 minus sine squared theta. Okay, and I'm going to do two things next. All right, so cosine of theta minus sine of theta cosine of theta, I'm actually going to factor that cosine back out. So really that means that first step of multiplying through by cosine was unnecessary. Okay, so again, let me just say I factored out cosine of theta. And then in the denominator, 1 minus sine squared of theta, you can use a Pythagorean identity on. Okay, that is equivalent to cosine squared of theta. All right, go back and look here. The original Pythagorean identity is this, that sine squared of theta plus cosine squared of theta is equal to 1, right? Well, if I manipulate that, I could say that cosine squared of theta is equal to 1 minus sine squared of theta, right? Just by subtracting sine squared over. So this is what I've ended up with in this particular identity of 1 minus sine squared, and I'm just rewriting it now as cosine squared. Okay, so that's a Pythagorean identity. Now hopefully you're seeing how that is helpful. I'm now able to reduce away cosine to 1, and then this cosine squared to just cosine. And ultimately, that is what I am trying to prove. Right? Put that check mark there to show that the identity has been verified.